All right, this lesson is called Area and Perimeter of Similar Figures. A few definitions to start. Recall that similar figures are figures that have the same shape but may have different sizes. Okay, those are called similar figures. They have the same shape but not necessarily the same size. This goes back to an earlier unit. Okay, their corresponding angles are congruent. The corresponding angles are congruent, and their corresponding sides, they're not congruent because that would mean that the two figures are congruent altogether. The corresponding angles are congruent, but the corresponding sides are proportional. Okay, corresponding angles are congruent and corresponding sides are proportional. And here's the big theorem for this lesson. Okay, perimeters and areas of similar figures. If the similarity ratio of two figures is A to B, or A over B, then the ratio of the perimeters is also A over B. And the ratio of the areas is A squared over B squared. Okay? All right. So we can use that for example one. Example one, the triangles to the right are similar. The ratio of the lengths of the corresponding sides is 6 over 9, which simplifies to 2/3. Find the ratio, and it says smaller to larger, of their perimeters. Okay? Well, the ratio of their perimeters is the same as the ratio of the sides. So the ratio of the sides is 2 over 3. So the ratio of the perimeters is also 2/3. And if I said larger to smaller, then it would be 3/2. And part B, find the ratio, smaller to larger, of the areas. This is going to equal 2 squared over 3 squared. This goes back to the theorem above, which equals 4 over 9. 2 squared is 4, 3 squared is 9. Okay? Example 2. The area of the smaller pentagon below is about 27.5 centimeters squared. Approximately, what is the area of the larger pentagon? So, let's look at the ratio of the corresponding sides. Okay? They're both regular pentagons, so it means they're similar. Okay? The ratio of the corresponding sides equals 4 over 10. Which you're going to simplify to make it easier to 2 over 5. That's the ratio of the corresponding sides. Now let's get the ratio of the areas. It's going to equal 2 squared over 5 squared. Which equals 4 over 25. Okay? Now we're going to solve for the area of the larger pentagon. We're going to have to use a proportion. Okay? The ratio of the areas is 4 over 25. So I'm going to do 4 over 25 equals. Since my first numerator is the smaller pentagon, 4 over 25, I'll put the area of the smaller pentagon up top, which is 27.5 in the directions, over x. So both of my numerators correspond to the smaller pentagon. Both of my denominators correspond to the bigger pentagon. Okay? And now we're going to solve that proportion for x. And that will be the answer to the problem. Okay? So remember, to solve a proportion, you're going to cross multiply. So 4 times x equals 25 times 27.5. So 4 times x equals 687.5. And x equals 171.875. So the final answer, the area of the larger pentagon is approximately 171.875 centimeters squared. Centimeters squared. Okay. All right, on to example 3. During the summer, a group of high school students used a plot of city land and harvested 13 bushels of vegetables that they gave to a food pantry. Their project was so successful that next summer the city will let them use a larger, similar plot of land. In the new plot, each dimension is 2.5 times the corresponding dimension of the original plot. How many bushels can they expect to harvest next year? Okay, so let's start with the ratio of the dimensions. It's 2.5 to 1. From that, because it's 2.5 times the original dimension, okay? From that, let's get the ratio of the areas. The ratio of the areas equals 2.5 squared over 1 squared. Two 2.5 times 2.5 is 6.25 over 1, because 1 squared is 1. Okay, so that's the ratio of the areas. Now let's set up my proportion. I'll do 6.25 over 1. So I'm doing the bigger area up top, okay? 13 corresponds to the year that they had the smaller area. So I'll put the 13 in the denominator. I'll put the x in the numerator. Cross multiply and solve for x, okay? X times 1, which is just x, equals 13 times 6.25. So it equals 81.25. And I'll round that to the nearest whole number. I'll say the students can expect to harvest about 81 bushels of vegetables next year. Okay, example 4. The area of the areas of two similar triangles are 50 centimeters squared and 90 centimeters squared. What is the similarity ratio? And what is the ratio of their perimeters? These answers are going to be the same. I just phrased it two different ways. What we're going to have to do is we're going to have to find the similarity ratio, which is A over B. So the areas, which is A squared over B squared, equals 50 over 98. That's the ratio of the areas, and that's represented as A squared over B squared. Now, let's simplify that fraction. Let's divide it by 2, and we get 25 over 49. I want to solve for A over B. I have A squared over B squared. So to do that, I take the square root of each side. So A over B is going to equal the square root of 25 divided by the square root of 49. So it's going to equal 5 over 7. And that is the answer. I'm going to say the similarity ratio is 5/7, and the ratio of the perimeter is 5/7. The question was phrased two different ways, so I'll write two answers. Okay. Oops. Let's say the similarity ratio is 5/7. And the ratio of the perimeters is also 5/7. Okay. And that's the end of that lesson. That lesson was called Area and Perimeter of Similar Figures.